guys, how are you all doing? So we'll talk about system of linear equation. That's how do you write the system of a certain linear equation. And before we start moving to the categories of solution, we have you talking about no solution, a single solution, and an infinite solution. And also before you start debunking about what we call the Gauss elimination method to solve it, you literally know that there's something interesting you need to understand about elimination, and also how do you put the elimination in matrix form, and how does even Gauss form itself? It's literally through what you have been learning before and the things that you are actually associated with before, but you don't just know the placing and the method. Now we talk about system of linear equation. And if you look at this certain particular equation being written now, it's just like a normal way of writing x plus y equals to 5, but instead of using different variable, we decide to just name x x1, then y x2. So we have in x1 plus x2 equals to 5 and 3x1 minus 2x2 equals to 10. Now we need two things in order to form our system of linear equation. That's our system in writing it. The first thing is we need to get the coefficients of each variables we are dealing with, and we put them in matrix form. So we know the coefficient of x1 here is 1, the coefficient of x1 here is what, 3, the coefficient of x2 here is what, 1, while the coefficient of x2 here is what, negative 2. In this point, we call this the coefficient of the matrix. Are you with me? Then literally we also need to put it in some certain form, which we are still going to expatiate or break down later on, but just need to understand it. Now, whenever you are including the solutions, also that's literally the constant values being given in the right hand side, in that point you can easily slash it, that is the variables and the constant answers being given, that's like the values. So in this point, whenever it is being slashed like this, whereby it is not dealing with only coefficients anymore, we call this an augmented what? An augmented matrix. So let's talk about how to use elimination and also the process of using elimination with the matrix in order to solve what a certain particular linear equation under a linear system. Alright guys, now let's check out solving normal them of the particular linear equation system with elimination method. Now if you look at this now, you will see that normally when you want to apply elimination method to a certain particular variable, you need to what? To check out the one you want to eliminate. And let's assume you want to eliminate x1. We are trying to solve it based on matrix method and also the normal method of elimination. Now what do? To eliminate, let's assume we want to eliminate x1, what do? We multiply the equation 2, equation 1 with what? With the quotient of x1 in equation 2 and what? The quotient of x1 in equation 1 multiplied into 2. And from there, whatever we do here, we also do it here. Now we consider this as row. This will be classified as row 1, this will be classified as row 2. The same thing, this is classified as row 1, this is classified as what? As row 2 under the augmented matrix. Now if you look at now what we just performed here, we said it's just like using 3 times row 1 under row 1 and 1 times row what? Row 2 under row 2. If you want to break it down into this particular matrix now, you can have this. Now you have 3x1, right? Plus 3x2 equals to 15. Then what do we have here? We still have our 3x1 minus 2x2 equals to what? Equals to 10. Then from there, if you want to break it down into the matrix also, we can say under row 1, what do? We multiply row 1 by 3, right? And under row 2, what do? We multiply row 2 by what? By 1. And from there, 3 times everything here, you have 3, and you have what? 15. Then 1 times everything here, you have 3, you have minus 2, and you have your what? Your 10. Can you see the process, the way it is moving? So just like we're trying to use the elimination method to explain some little things for you to understand. So the elimination method is like the basic of you understanding like the baby aspects before you now start moving into Gauss elimination method itself. So from this aspect now, what do we need to do again when you think? Our next term under elimination method is what? We subtract, right? And let me tell you something now. What you need to know is that whenever a particular system is breaking down into one, it will be considered as just like a normal first row. Are you with me? So whatever you are doing here, now look at what I'm saying. 3x1 minus 3x1, you have what? 0, right? Minus times minus, you have plus, this gives us plus what? Plus 5x2 equals to 15 minus 10, you have what? You have 5. Now this can be considered as a single row. That means this operation that we just did now can be classified under row 1. Are you with me? And what's the operation we did now? We use row 1 to subtract row 2. The result you are getting would be placed on what? On row 1. Now that means my operation now under row 1, what did I just do? I did what? I said row 1 minus what? Row 2. And what was my answer? Row 1 minus row 2, that is 3 minus 3. You have what? 0. My answer will be on row 1. 3 minus what? Minus 2. You give me what? It gives me what? 5. Then 15 minus 10 gives me what? It gives me 5. Then I put my row 2 back. I don't have issue with row 2 yet. Are you getting what I'm saying now? So my problem is under row 1. This is to signify the problem where the problem is to be situated. R1, 3R1, R2, the problem is under R2, 1 times R2. So the problem is under R1, R1 minus R2. So from here now, you don't have 0, 5x2 equals to 5. And I'm looking for x2, not 5x2, because I need a variable of 1. You get my logic? So from there now, what do we do next? We can divide both sides by what? By 5. Then from there, I have 5x2 divided by 5 equals to 5 over what? Over 5. And you know time, my x2 will be equals to 1. Now I can apply the same thing. I can do, don't forget, we are still under row 1. So to make row 1 now, I can say still under row 1. What do I do? Now literally, you can go straight to the point, but I'm trying to break it down step by step so that you can understand the logic behind this. Now under row 1 now, what do I just do? I can say that what? Row 1 divided by what? By 5. So from there, I have 0, 5 over 5, I have 1, 5 over 5, I have 1. I don't have issue with row 2 yet in my 10. Are you with me now? So from there now, you can see that what? I've gotten the situation or the answers to what? To row 1 issue. And how do I get it? I have to make sure that row x1 is 0 for me to get x2. That means that for me to also get x1, I have to make x2 0. Hope you are getting my logic. Now, whenever you want to solve for the second row, we need to actually adjust to thinking of how to make this one 0. I will make it will be the same pattern with getting answer for linear equation, but there will just be a little thing of thinking mentally by saying, how do we change this to what? To 0? And how do we perform that? It is a normal way. A normal way of whereby you can subtract row 1 from row 2. You can do any sort of what? Any sort of calculation. So far, it is actually following the what? The track. And look at what I'm saying now. Let's look at this certain particular category. Now, you know that if you have to pick from, let's say you have from equation 1, which is x1 plus x2 equals to 5, right? You know you can easily get your x1 by substituting it. Now, we want to put it in the normal way. Are you with me? For equation 1. Now, what do you think we can do first of all? You should know that this one cannot become 0. If I say row 1 minus row 2, it's just 1 minus 2, which will give me 3. So that means I can first of all say multiply row 1 by 2. Now listen, whatever I'm doing, if I indicate it, even though I say 2 times row 1 under this particular sign, it won't affect row 1. Everything will be affecting what the certain row I indicated. And if you look at now, we know we are dealing with row 2 now. So under row 2, if I'm to say that I multiply row 1 by negative what? Negative 2. Minus 2 times row 1, it will not affect row 1 because my problem all are going to lie is in what? In row 2. So minus 2 times row 1, then I can say now subtract it from what? From row 2. And if you look at now, it will work. Minus 2 times 0, I have what? 0. 0 minus 3. And I told you it does not affect this. You put your 0, 1, and 1. Now, 0 minus 3, what do I have? I have minus 3. Right? Then next thing again, the second one. Minus 2 times 1, I have minus 2. Then minus 2 minus minus 2. That will give me what? 0. I have my 0. Can you see the logic behind this now? Now from there again now, what do I do next? Then, if I look, minus 2 times this, I still have minus 2. Then minus 2 minus 10, I have what? Minus 12. So from my aspect of view, I could easily say that what's breaking this down now. Say that breaking this down, and if you look at now, x2 is 1. I can have x1 plus what? Plus 1 equals to what? Equals to 5 here, right? So we are still moving, just like you having 1, 1. But this one has to turn to 0. Do not forget. Just like a normal differential logic. If I'm to use this, we are still going to be talking about the same thing here. Are you getting what I'm saying? That is the same thing in the aspect of saying divide. This one becomes minus 2. Minus 2 comes back here to become what? 8. Are you with me? But if you throw it back here, this becomes 12 rather, then you divide it by what? By 3. You get my logic? So even though I put 3x1 minus 2x2 equals to 10, just to follow the same pattern. And if you look at now, what do we just do? you have to make this 0, right? That's making x2 become a normal 0 variable. And from that, now if you look at, I have 3x1 minus 2 because x2 is 1 equals to what? To 10, right? Now if you look at, now what do I just do? I can throw this back to here, and this will become ordinary 3x1 what? Plus nothing here equals to what? 12. Hope you are getting my logic now. Hope you are getting my logic. And I can still do what I did there. I can still say multiply everything here by what? Minus. It will become minus 3x1. If I say multiply by minus, just for a normal clear intuition, you know, this will become minus 3x1. Nothing will be left here. This will become plus 2. And this will become what? Minus 10. You get my logic? Then this will still be giving you minus 3x1 equals to minus what? Minus 12. Just like what we are having here. And what do we need to do next here? We divide both sides by minus 3 over minus 3. The same thing is applicable here. Under row 2, what do we do next now? We do what? We divide row 2 by what? Minus 3. And nothing concerns row 1. Just like I have said. So minus 3 over minus 3, you have 1. This will become 0. And minus 12 minus this will become what? 4. And from there, our x1 here also is equals to what? 4. Hope you get my logic now. So you can see that literally it works for the same way. But this is just like breaking it down in a baby step of what we need to follow. We won't be using the elimination method to follow up something like this again when you get with some Combination expression like s1 s plus s2 plus s3 plus s much more. Elimination method won't help you anymore. You have to move on to some standard method. So that is why we're just trying to express it in a way where you understand it first before we move into the certain particular expression. So if you look at this expression, it's just like you saying 0x1 plus x2 equals to 1 and 1x 1 plus what? 0x2 equals to 4. You get what I'm saying? Where x2 is equals to 1 and what? x1 is equals to 4. This is like the basic aspect of applying the normal method. So we'll actually look into applying the elimination method again to see a little bit much more expression that is more than this. By applying, like I told you, you can apply straight method by also using the mental method to operate it with what? With the matrix method. Thank you.